All right, AP Calc students, welcome to your secret weapon for the exam. We're about to tackle one of those topics that can really trip people up, the derivatives of inverse trig functions. Let's just dive right in.
Okay, picture it. It's test day. You flip the page, and this thing is staring you in the face. What do? Does your brain kind of freeze up? Well, stick with me, because by the end of this, you're going to see a problem just like this and think, oh, I got this. We're going to turn that panic into pure confidence. So here's our game plan. First, a real quick look at what these inverse functions even are. Then we'll talk about the chain rule, your absolute best friend here. After that, we'll hit the formulas you gotta know, work through a problem together, and finally, I'll give you a quick toolkit for exam day. Let's do it.
First up, a quick refresher. I mean, you can't really find the derivative of something if you're not 100% sure what that something is, right? So let's make sure we're on solid ground. Think about it like this. An inverse function just runs the machine backwards. With a normal sine function, you pop at an angle and it spits out a value. Simple. Well, with its inverse, arcsine, you do the opposite. You feed it the value and it tells you which angle gave you that value. And you'll notice those restricted domains and ranges. That's super important. It's how we make sure the machine gives us just one single answer back, not an infinite number of them. Okay, section 2. Now we're talking about the chain rule. And listen, if there's one thing you take away today, let it be this. The chain rule is not just a tool, it is the tool. It's your master key for basically all the tough derivative problems on the AP exam. Get this down and you're golden. And then you see this, the formal definition. I know, it looks like a bunch of alphabet soup. F of g of x, h prime. It can totally make your eyes glaze over. But I promise you, the actual idea is way, way simpler than this notation makes it seem. So let's just break it down into 3 simple steps. I always think of it like those Russian nesting dolls. First, you take the derivative of the biggest, outermost doll. Then, and this part is key, you just leave all the inside stuff alone for a second. Just copy it over. Finally, you multiply that whole thing by the derivative of the next doll on the inside. So just repeat this in your head. Derivative of the outside, leave the inside alone, times derivative of the inside. That's it. That's the whole game. All right, so you've got your master key. What locks is it going to open? Let's get to the main event. The 6 big formulas you're going to need. And just as a little side note, these aren't magic. They all come from a process you probably already know, implicit differentiation. We won't get into the weeds with that, but it's pretty cool to know where they come from. Okay, here they are in all their glory. Now don't panic, it looks like a lot, but notice the chain rule is already baked right in. That u you see everywhere, that's our inner function, our smaller nesting doll. And that u prime in the numerator of every single one, well, that's the derivative of the inside part we just talked about. So go ahead, pause, and take this in. But trust me, you do not have to memorize all 6 of these from scratch. Because here is the secret. This is the hack that's going to save you so much brain space. You don't need to memorize 6 things. You only need 3. Why? Just look at the cofunctions, arc cosine, arc cotangent. See how their derivatives are just the negative of their buddies? Arc sine and arc cosine? Same exact formula. One just has a minus sign. It's a game changer. Just learn the rules for arc sine, arc tan, and arc sec, and you get the other 3 for free. You literally just cut your work in half. You're welcome. Okay, enough with the rules and theory. Let's get our hands dirty and actually do one of these. This is where it all comes together. We're going to take our key, the chain rule, and use it on one of these new locks. All right, here's our problem. This is a classic AP-style question. We need to find the derivative of arctan of 3x. Looks a little intimidating maybe, but we've got a system. Let's just follow the steps. So, step 1, always, what's our u? You gotta identify that inner function first. In this case, what's the piece that's been plugged into the arctangent function? Yep, you got it. The outer function is arctan, and the inner function, ru, is 3x. So, what's the derivative of the inside? Well, the derivative of 3x is just 3. That's our u prime. See? We've already got all the ingredients we need. Now we just put it all together. Remember the formula for arctan? It's u prime over 1 plus u squared. So let's plug in our parts. U prime is 3, that goes on top. U is 3x, so that goes on the bottom where we have to square it. And what's 3x squared? Be careful, you gotta square the 3 times the x. That gives us 9x squared. And boom, there it is, our final answer. 3 over 1 plus 9x squared. See, it's not magic, it's just a repeatable process. Okay, let's wrap this all up. Think of this final section as your toolkit, your personal cheat sheet for test day. These are the absolute must-knows to walk away with. Here it is, your 5-point survival guide. Number 1, the chain rule is king. Live it, breathe it. Outer derivative times inner derivative. 2, you only need to memorize 3 formulas, not 6. Arcsine, arctan, arcsec. That's all. 3, remember that cotrick. The other 3 are just the negative versions. 4, your first move every single time is to figure out what u is. And 5, and please, please, please don't do this. Don't forget to multiply by u prime. That is the number 1 most common mistake. Don't let that be u.
And that's pretty much it. You have the system, you've got the formulas, and you've got the strategy. You are now equipped to tackle any inverse trig derivative problem the AP exam throws at you. So the only question left is, how are you going to lock these patterns down so they're second nature on test day? Think about it, because you are ready. You've got this.